The universe is vast, teeming with billions of galaxies, each containing billions of stars. Yet, amid this cosmic abundance, a profound silence reigns. We listen, we search, but the stars offer no reply. Where is everyone? This is the Fermi Paradox, a question that challenges our very place in the cosmos. Join us as we unravel the mystery of the silent universe and explore why, despite the overwhelming odds, we appear to be utterly alone. The Fermi Paradox, a cosmic conundrum. The vastness of the universe presents a profound question. If life is common, where is everybody? This is the essence of the Fermi Paradox. We observe countless stars, many with orbiting planets, and the conditions for life appear to be present in numerous locations. Given billions of years of cosmic history, one might expect that at least some of these potential cradles of life would have evolved into advanced civilizations capable of interstellar communication or travel. Yet, the silence from the cosmos is deafening. No alien signals have been definitively detected, no probes have visited our solar system, and no evidence of extraterrestrial megastructures has been observed. This stark contrast between the high probability of alien life and the utter lack of evidence for it is what makes the Fermi Paradox so compelling and perplexing. Several hypotheses attempt to resolve this paradox. One set of explanations suggests that intelligent life is exceedingly rare. Perhaps the emergence of life itself is a fluke, or the evolutionary jump to complex, intelligent beings is an astronomically improbable event. Another possibility is that civilizations, upon reaching a certain technological threshold, inevitably destroy themselves through war, environmental collapse, or runaway artificial intelligence. This great filter could lie in our past, meaning we are among the very few to have overcome it. Or it could lie in our future, a grim warning of what awaits advanced societies. Alternatively, advanced civilizations might exist, but choose not to communicate or interact with us. They could be deliberately observing us, following a non-interference policy akin to a zoo hypothesis. Perhaps their communication methods are so advanced or alien that we simply cannot recognize them, or they exist in forms we cannot comprehend, such as post-biological entities or beings dwelling in dimensions beyond our perception. Another idea is that interstellar travel is far more difficult or less desirable than we imagine, effectively isolating civilizations within their own star systems. The sheer scale of the universe, with its immense distances and the finite speed of light, could also be a fundamental barrier, making contact practically impossible even if civilizations are abundant. The Great Filter Hypothesis. The Great Filter Hypothesis proposes that somewhere along the path from the beginning of life to a galaxy-spanning civilization, there exists a barrier so difficult to overcome that it explains the apparent absence of extraterrestrial intelligence. This filter could be a single, monumental challenge or a series of smaller, cumulative obstacles. If the filter is behind us, it implies that the emergence of complex life, or even intelligent life, is incredibly rare. Perhaps the leap from non-living matter to self-replicating organisms is a near impossibility, or the development of multicellularity, or the evolution of consciousness. Earth might be an anomaly, a statistical outlier that miraculously passed through these early, formidable hurdles. Alternatively, the Great Filter could lie ahead of us. This is a more sobering prospect, suggesting that advanced civilizations invariably encounter a self-destructive tendency or an insurmountable cosmic challenge. Potential future filters include uncontrollable artificial intelligence, catastrophic environmental collapse due to advanced technology, the inability to manage resources on a planetary or interstellar scale, or perhaps even a natural cosmic event that regularly sterilizes advanced life. The silence we observe in the universe, then, would be a grim warning of what awaits any civilization that reaches a certain technological threshold. Consider the implications of this hypothesis. If the filter is in our past, it suggests humanity might be unique, or at least among a very select few, in the observable universe. This places an immense responsibility on us to survive and thrive, as we may be the sole custodians of consciousness in our cosmic neighborhood. Conversely, if the filter is in our future, it implies that the technological advancements we are so eagerly pursuing could be the very instruments of our own demise. The Fermi Paradox, with its stark question of where is everybody, finds a compelling, albeit unsettling, answer in the concept of a great filter. This filter acts as a cosmic sieve, allowing only a tiny fraction of potential life to progress to the stage where it could be detectable across interstellar distances. The absence of signals, therefore, is not necessarily an absence of life, but an absence of detectable, advanced life, suggesting that most life forms fail to pass this crucial, enigmatic barrier. Rare Earth Hypothesis. The rare Earth hypothesis posits that the development of complex life, like that on Earth, is an exceptionally rare event. It suggests that while simple microbial life might be common throughout the universe, the specific combination of astrophysical and geological circumstances required for multicellular organisms to evolve and thrive is highly unusual. This hypothesis attempts to resolve the Fermi paradox by proposing that the conditions necessary for intelligent life are so stringent that Earth may be one of the very few, or perhaps the only, planet in our galaxy to meet them. Consider the sheer number of factors involved. A stable star, not too large to burn out quickly and not too small to be prone to violent flares, is essential. The planet must reside within the habitable zone, where liquid water can exist on the surface. Furthermore, a large moon is crucial for stabilizing the planet's axial tilt, preventing drastic climate fluctuations. Earth's magnetic field, generated by its molten core, shields the surface from harmful solar radiation, another vital component for life's survival. Beyond these astronomical prerequisites, geological factors are equally important. Plate tectonics, for instance, plays a significant role in regulating climate over geological timescales by recycling carbon. The presence of Jupiter-like gas giants in the outer solar system can also act as a protective shield, deflecting many comets and asteroids that could otherwise cause mass extinction events. The precise composition of a planet's atmosphere, the abundance of specific elements, and the evolutionary history of its biosphere all contribute to the intricate web of conditions that support complex life. The rare Earth hypothesis does not deny the possibility of life elsewhere, but it argues that intelligent, technologically advanced life capable of interstellar communication is exceedingly rare. The unique confluence of events that allowed life to emerge, evolve complexity, and develop intelligence on Earth might be a cosmic anomaly. This perspective suggests that the silence we perceive in the universe is not due to a lack of effort in searching, but rather a fundamental scarcity of suitable candidates for such signals to originate from. The Zoo Hypothesis. The Zoo Hypothesis suggests that advanced extraterrestrial civilizations are aware of humanity but deliberately avoid contact, treating Earth as a cosmic zoo or wildlife preserve. This non-interference policy is maintained to allow human civilization to develop naturally, without external influence or disruption. Such a scenario implies that aliens possess the technology for interstellar travel and communication, and have likely observed us for a considerable time. They might be studying our social structures, biological evolution, and technological progress from a safe distance, much like we observe animals in a zoo or in their natural habitats. The implications are profound. We are not alone, but our cosmic neighbors have chosen to remain hidden, perhaps for ethical reasons or simply out of scientific curiosity. This hypothesis attempts to reconcile the apparent contradiction between the high probability of alien life existing and the lack of observable evidence. Consider the possibility that Earth is a carefully managed environment. Alien civilizations, far more advanced than our own, might have established a prime directive similar to that depicted in science fiction, forbidding direct interaction with less developed species. This could be to prevent cultural contamination, avoid causing panic, or simply to ensure that our development follows an unadulterated path. Their observation methods could range from sophisticated remote sensing to cloaked probes monitoring our planet. The silence we perceive in the cosmos would then not be a sign of emptiness, but rather a deliberate act of concealment by a galactic community that chooses to keep us in a state of enforced isolation. This cosmic zoo might extend to other developing civilizations, creating a network of hidden worlds observed by a mature galactic society. Another facet of the zoo hypothesis involves the sheer scale of the universe and the potential diversity of life. If advanced civilizations exist, they may have vastly different motivations and ethics than humans. Their decision to withhold contact could stem from a recognition of our immaturity as a species, or a desire to avoid the unpredictable consequences of revealing themselves. They might be waiting for us to reach a certain technological or social threshold before initiating contact, or perhaps they have deemed us not yet ready for such an encounter. The absence of signals could be interpreted not as a lack of communication, but as a deliberate choice to maintain the integrity of our developmental trajectory, ensuring that any future contact is on their terms and when they deem us ready. This implies a level of foresight and control over cosmic affairs that is currently beyond our comprehension. Furthermore, the zoo hypothesis offers a framework for understanding why no definitive evidence of alien visitation or communication has been found despite decades of searching. If we are indeed in a cosmic preserve, any signals we might detect could be intentionally misleading or simply part of the exhibit. Advanced aliens could easily mask their presence, rendering their technology undetectable to our current scientific instruments. Their silence would be a product of advanced capabilities, not a lack of existence. This hypothesis provides a plausible, albeit humbling, explanation for the Fermi Paradox, suggesting that the vastness of space may be populated, but our understanding of our place within it is fundamentally incomplete due to a deliberate choice made by others. Extraterrestrial intelligence, detection challenges. The search for extraterrestrial intelligence, SETI, faces profound challenges, primarily centered on the difficulty of detecting signals from civilizations that may be vastly different from our own. The sheer scale of the universe presents a daunting obstacle. Our current methods rely on detecting electromagnetic radiation, such as radio waves or optical signals, that alien civilizations might intentionally or unintentionally emit. However, the cosmos is immense, and the number of stars and potential planetary systems is astronomical, making a comprehensive search virtually impossible with present technology. We are essentially searching for a needle in an infinite haystack, and we don't even know what kind of needle to look for. One of the significant hurdles is the technosignature problem. What constitutes a detectable sign of advanced technology? We tend to look for signals similar to those we produce, like radio broadcasts. But an alien civilization might use communication methods entirely unknown to us, perhaps based on principles of physics we haven't yet discovered or mastered. They might have moved beyond electromagnetic communication to something more efficient or subtle. For instance, they could be using modulated neutrino beams, gravitational waves, or even forms of communication that are currently purely theoretical. Our assumptions about what constitutes a signal might be fundamentally flawed, limiting our search to what is familiar rather than what might actually exist. Furthermore, the concept of listening implies a continuous or targeted effort. Given the vastness of space, even if intelligent signals are being broadcast, they might not be directed towards us, or they might be too weak by the time they reach Earth to be detected by our current instruments. The inverse square law dictates that signal strength diminishes rapidly with distance. A civilization that is thousands or millions of light years away would require an incredibly powerful transmitter to send a detectable signal across such an expanse. Alternatively, they might exist only for a brief period in cosmic history, making the chances of simultaneous existence and detection slim. Another challenge is the potential for alien civilizations to be quiet. They might have evolved beyond detectable technologies, perhaps developing highly efficient, localized communication systems, or transitioning to forms of existence that do not produce easily detectable technosignatures. Some theories suggest that advanced civilizations might deliberately conceal their presence to avoid potential threats, a concept known as the dark forest hypothesis. This would mean that any signals we might detect could be intentionally misleading or absent altogether, adding another layer of complexity to the detection problem. The very nature of intelligence might lead to behaviors that make detection exceptionally difficult. The nature of advanced civilizations. The nature of advanced civilizations remains a profound enigma, a critical component of the Fermi Paradox. These civilizations, if they exist, may operate under principles vastly different from our own, making their detection or interaction improbable. One hypothesis suggests that advanced extraterrestrial intelligences might evolve beyond the need for physical expansion or resource exploitation. Their development could lead them to virtual realities, immense computational endeavors, or forms of existence we cannot yet comprehend. Such civilizations might exist as pure energy or in dimensions inaccessible to our current scientific understanding. Their silence would then be a consequence of their transcendence, not their absence. Another possibility is that advanced civilizations prioritize long-term sustainability and stability over rapid growth. They might have learned from the mistakes of younger, more aggressive species, including ourselves, and adopted a philosophy of minimal interference and conservation. This could involve strict protocols against broadcasting their presence or engaging with less developed civilizations until a certain threshold of maturity is reached. Their technological prowess might be directed inward, focusing on perfecting their own existence and understanding the universe, rather than outward exploration and communication. This self-imposed quietude would explain the lack of detectable signals, as they would actively avoid broadcasting their existence across the cosmos. Furthermore, the very definition of civilization or intelligence might need reevaluation when considering extraterrestrial life. We tend to anthropomorphize, projecting our own values, motivations, and technological trajectories onto potential alien species. An advanced civilization might not be driven by curiosity, conquest, or even a desire for connection in the way humans are. Their evolutionary path could have led to a collective consciousness, a form of existence where individuality as we know it is subsumed, or perhaps a focus on art, philosophy, or exploration of consciousness itself, rather than material or technological advancement. Their advanced state could simply mean they are better at not being noticed, or that their forms of communication are so alien that we lack the framework to recognize them. Implications for humanity. The Fermi Paradox, in its stark silence, forces us to confront our place in the cosmos. If intelligent life is statistically probable, then its absence, or at least its undetectable absence, suggests profound implications for humanity's future and our understanding of life itself. This silence could indicate that the emergence of complex, technological civilizations is an extraordinarily rare event, making us a unique, perhaps solitary, instance in the observable universe. Such a realization would imbue humanity with an immense responsibility, a cosmic imperative to survive and thrive, as we might be the sole custodians of consciousness in a vast, empty expanse. Alternatively, the silence might be a warning. Advanced civilizations could be inherently self-destructive, succumbing to technological or societal collapse before they can achieve interstellar reach. This great filter hypothesis posits that some insurmountable barrier prevents civilizations from becoming widespread. If this filter lies in our past, perhaps in the transition from simple to complex life, then humanity has already overcome a great hurdle. However, if the filter lies in our future, it implies that every advanced civilization eventually faces an existential threat that it cannot overcome, a chilling prospect for our own long-term survival. The implications extend to our search for extraterrestrial intelligence, SETI. The lack of detected signals could mean our methods are flawed, our assumptions about alien communication are incorrect, or that civilizations simply do not broadcast in ways we can detect. Perhaps advanced species transcend physical communication, existing in forms we cannot comprehend, or they deliberately choose to remain silent, adhering to a non-interference policy. This profound mystery underscores the limitations of our current knowledge and the vastness of what we do not yet understand about the universe and the potential forms life might take within it. The silence, therefore, is not merely an absence of evidence, but a powerful, albeit unsettling, source of information about the potential trajectories of intelligent life. The vast silence of the cosmos, a stark contrast to the bustling potential of life, presents us with the Fermi Paradox. Where is everybody? We've scanned the skies, listened for whispers across the light years, yet the universe remains eerily quiet. Is intelligent life a cosmic rarity, a fleeting spark in the grand darkness? Or are we simply not listening correctly, or perhaps not looking in the right places? The silence doesn't negate the possibility. It deepens the mystery, urging us to continue our search, to refine our methods, and to ponder our place in this immense, silent theater. What if the answer lies not in the stars, but within ourselves, or in the very nature of consciousness? Join us next time as we delve into the mind-bending concept of the Great Filter and explore the potential existential challenges that might explain humanity's solitary journey through the universe.